Hello everyone, and thanks for coming back. We have already finished the first question of exercise 3.2 in our previous video, and we are continuing with the chapter of pair of linear equations in two variables. This is a very interesting chapter, and we have to move to question number 2. In question number 2, they are asking us to compare the ratios of a1 by a2, b1 by b2 and c1 by c2. So these are the ratios of the coefficients of x, coefficient of y and the constant terms. And after comparing, we have to find out whether the lines representing the equations, they intersect at a point, or are they parallel, or they are coincident. So we have learned that if we compare the ratios of the coefficients and the constant term of the two equations, then we can find out whether those are intersecting lines, or they will be parallel lines, or they would be coincident. Let's go through that one time. Go through this now. Look at it. We have already done in the concepts. So if a1 by a2 is not equal to b1 by b2, so the ratio of coefficients of x and ratio of coefficients of y are not equal, then they would form intersecting lines. And if the ratios of coefficients of x and coefficients of y and the constant terms is equal, then they are coincident lines, right? And if the ratios of coefficients of x and y are equal, but then they are not equal to the ratio of constant terms, then those are parallel lines, right? So let's go to the question. So here is the first part. We have two equations, 5x minus 4y plus 8 is equal to 0 and 7x plus 6y minus 9 is equal to 0. So let's write down the coefficients in the terms of a1, b1. Let's move to the solution. So we have, for the first equation, a1 is equal to 5, a2 is equal to 7. Coefficients of x and then coefficients of y, b1 is equal to minus 4 and b2 is equal to 6. For the constant terms, we have c is equal to 8, c1 and c2 is equal to minus 9. So we have already written all the coefficients. Now let's compare them. Let's write down the ratios. a1 by a2 is equal to 5 by 7, b1 by b2 is equal to minus 4 by 6 and c1 by c2 is equal to minus 8 by 9. Okay, so now I can see that none of the ratios are equal. So I can say a1 by a2 is not equal to b1 by b2. These would be the intersecting lines, right? So these are, I can write down that these are, these lines will intersect at a point. Let's move to second pair of equations. So in this we have a1 is equal to 9, a2 is equal to 18 and b1 is equal to 3, b2 is equal to 6 and c1 is equal to 12 and c2 is equal to 24. Let's find out the ratio. So a1 by a2 is equal to 9 by 18. So this is also equal to 1 by 2, while b1 by b2 is also equal to 3 by 6, so 1 by 2. Okay, and c1 by c2 is 12 by 24. So this is also equal to 1 by 2. So I can see that all the three ratios are equal. So I can say that a1 by a2 is equal to b1 by b2 is equal to c1 by c2, and we know if the three ratios are equal, then they have infinitely many solutions as they are coincident lines. These lines will be coincident lines. These lines will be coincident. Move to third set of lines. So this pair, let's find out. A1 is equal to 6 and A2 is equal to 2. B1 is equal to -3. B2 is equal to -1. C1 is equal to 10 and C2 is equal to 9. So I have got the coefficients and the constant terms. Now let's find out the ratio. So A1 by A2 is equal to 6 by 2. So I have 3 here, and B1 by B2 is equal to -3 by -1. So this is also equal to 3, while C1 by C2 is equal to 10 by 9. So I can see here that A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2, right? So these type of lines are parallel lines. So these lines would be parallel. We were supposed to find out whether the lines are coincident, parallel, or intersecting at a point. So we have done this question. So next question we'll do in the next video. So stay tuned and see you guys.